to high school. Those of you that are ninth graders will be considered as high school students this year. And as I tried to explain to you at the end of last year, your 8th grade year was the last year that doesn't count. This now does. And so we will take a very serious look at things. You need to mature and grow up and be a high school student. We're going to cover a lot of material. Now that we've had a year under our belts of how to do Carnegie and the process that needs to happen for you, just better get ready, because we're going to just fly through a bunch of stuff here. If you get behind, don't. What we're going to do is what we did similar to the end of last year. We're going to flip the classroom. All of your lectures and discussions will be on the internet. That will be what you do at home. You'll then bring your books, and you will then do your work in class. We'll work in groups, and we'll divide those groups up, and I'll explain in class how we're going to do that so that everybody everybody has a chance to participate, and everybody does their fair share. We'll do this much like we did last year. We'll put some pages up on the website. I will write on those pages and show you how to do examples and those sorts of things. Then you will come to class fully prepared to do your work. So welcome. We're looking forward to a fun year. We're going to do multiple things, more than just math. I want you to know that. I've got some good things planned. We are part of a pilot program for the state of Utah that will allow us to use computers and do some work there. I've also got a plan to do something outside of math to help us all understand how we need to succeed and what we need to do to succeed. So hopefully it'll be a good year for you, and we'll have a good time. So get ready. We're going to just turn to the next slide and get started on this. All? Okay. Got a ball. As you can see from this page, there are only 4 sections, and we'll do at least a section or 2 a day, more than likely 2, sometimes 3. With the A-B schedule, we're not going to waste time waiting and just doing 1 section at a time. We'll do 2, maybe 3. So if you take a look at this and break it down, sections 1.1 and 1.2 will be done in 1 day, 1.3 and 1.4 the next day, do a little review, and be ready for the test. So, like I say, we're going to go very fast. Excuse me. You should be able to keep up, work in your groups. If you do what you're supposed to do, there won't be any problems. If you don't do the tasks, and if you don't do the stuff at home, then you're going to run into difficulty. But you have access to everything that I'm going to discuss at home at all times. So if you don't get some concept, you can always go back and get it. Here we have what's going to be at the beginning of every section, some learning goals that we have, and some key terms. This, of course, is just exactly like we had last year in that book. So in this lesson, you'll understand quantities and their relationships, identify the independent and dependent quantities for a problem situation, and that's what's right here, understanding the terms dependent and independent, and I'm going to give you a little review here in just a second. Match a graph with the appropriate problem situation. In other words, learn to read a graph and remember which equation it goes with, whether it's time, distance, steep slope, negative slope, no slope at all, if it's a function or not a function. All of those things that we learned right at the end of last year, you should be able to deal with. And then review and analyze the graphs and describe similarities and differences among graphs. Now, before we go on, I want to do just a little bit of a review with you. Many of you should be familiar with this. X and Y. It's a table that we used over and over and over again. This is the domain. Oh, that didn't work very well. The domain. This is the range. Let me stop and make another one that's going to be a little bit better for you. Okay, let's do it again. This is X, this is Y, domain, range, input, output. Remember, in input and output we talked about video games, where you have the controller and you are the input, and as you manipulate the controller, what you see up on the screen of the TV or your computer is the output. This is independent. This is dependent. We get to choose X, and remember, we generally chose -1, 0, and 1 for the values. So these terms, domain and range, input, output, independent and dependent, you should again be familiar with those. We're going to use those over and over and over again. You should remember how to graph them on an XY axis. There are various formulas that go with these. The most common, y equals mx plus b. And that's not a very good equal sign. Y equals mx plus b was our most used equation. We had equations with absolute values. We had equations with exponents. We learned what a function was by drawing a straight line. The vertical line example, if it crosses the graph twice, then it's not a function. All of that should be very familiar to you as we begin this next section. It's a review of what we've done in the past, as well as a chance for you to grasp the concept and the review of graphing. On this particular page, we're very interested in dealing with the dependent quantity and the independent quantity. And up in here, as we begin this, they want you to circle and underline the dependent and the independent quantities. You can determine whether or not you want to circle the dependent and underline the independent, or vice versa. It doesn't really matter, but learn to see them. The number of hours is certainly something that we would take a look at, and the money earned, they are in relationship to each other. Your task is to determine which is dependent and which is independent, and you'll do that throughout this whole page. Again, this page is just sitting here asking you to read some information and then determine what the independent quantity is and what the dependent quantity. The same thing with a smartphone. If you're going to purchase this smartphone, is it a smart deal? How do you know which is dependent, which is independent? The last few pages were all the same, so I didn't stay up very long. You can just read those in the book. Now what we're going to do is we're going to have you cut some graphs out. You've done this in the past. Cut some graphs out, get the glue out, sniff the glue, and then put stuff on the paper and match up graphs with information that you can take a look at. Here's an opportunity for you to be a little bit independent and see how you would match things up. You don't have to necessarily follow with everybody else. One good thing about this course is that you do have the chance to do things independently. So you'll have some time to do this in class. Cut them out, label them, check what you want to, which ones you think match up. There's no right or wrong answer here, just match them up. On this page, we just want you to answer the questions. What similarities do you notice? What differences do you notice? How did you label the independent and the dependent quantities in each graph? And analyze each graph from left to right and describe any graphical characteristics that you notice. Again, I want you to use full sentences. These are not just 1 or 2 word answers. They need to be full sentences. Now in section 1.2, we've got a few more key terms. The terms here, the relation, domain, range, function, vertical line test, discrete graph, and continuous graph. Those are terms that we used last year. We know what the domain and the range is. A function on a graph is something that passes the vertical line test, and a discrete graph and a continuous graph. Discrete does not have lines between the dots, and a continuous graph does. And so as you analyze the graphs that you're going to be seeing in this particular section, these terms right here are the ones that are going to be of value to you. and they ought to be familiar to you because we've done them in the past. And when you get into the class, take a look and read this scenario here. You're getting the urge to start driving. Chances are you'll be studying for the driving test. But how much will it cost you to drive, and how much is it going to cost your parents to have you drive, and will they pay for the insurance, and who's going to put the gas in the car? All of those are a factor in your starting to drive. So just something for you to think about as you read this page. Here again, we're going to cut out graphs, and I'm going to skip some pages here because you can cut out the graphs and paste them on the paper in your book. This gives you a chance to speculate. Matthew grouped these graphs together. Why do you think he did that? Because it was easy? What's unique about them? And again, more than just one sentence or one word. It needs to be a full sentence. Explain what you're thinking. And this is going to be, you're going to be asked to do this for several pages. So again, I'll just skip through them. This is a very important page. We're going to talk about relationship. The relationship is the mapping between a set of input values called the domain and the set of output values called the range. A function is a relation between a given set of elements such that for each element in the domain there exists exactly one element in the range. And you've done mappings of those. If you remember, we did this last year. So you're going to take all the information that's in the range, the x value, the domain, the x value, all of those values have to be able to be mapped to exactly one element, to at least one element in the range portion or the y portion of the table. The vertical line test, we mentioned that at the beginning, is a visual method used to determine whether a relationship represents a function or not. If I draw this over here and I draw this particular line, no matter where I draw that vertical line, it only crosses in one place, and that is a function. However, if I graph this and I try the vertical line test, that's not a function. Okay? And circles are not functions. That would be a function. That would be a function because the vertical line test works. Sorry I had to draw so many things on there, just ran out of room. But I think you remember from last year the tests that we took a look at. A discrete graph has isolated points. A discrete graph looks like this. A continuous graph looks like that. So understand the terms continuous and discrete so that you can analyze the graphs that are coming up. You'll then do the talk-to-talk. I didn't put all the talk-to-talk pages in here. I figured you could see them in the book. And that should finish us up for the day.